Hello and welcome to Cheg's live office hours. If you're just now rolling in, this is the Stoichiometry Office Hours. Chegg is so kind as to offer these sessions all week long, so I encourage you to check out the list of all the course office hours that they offer and get on those to help you with your classes that you're taking this semester. I'm Allison. I'm a chemical engineering student at the University of Louisville. I have TA'd for chemistry, calculus, organic chemistry, and then I've been a learning assistant for those classes too. I've had a lot of teaching experience. I love tutoring, and tonight I'm here to help you guys with any stoichiometry chemistry questions that you all have. I want you guys to type those questions in the chat so that I can see them and that I can answer them for you. My goal is to help you with any questions that you have. I've prepared some for us to start out with, but I would love to answer yours, so please feel free to ask me those questions. So I've started us up with some warm-up problems. If you don't know these off the top of your head, that's okay. That's what we're here for, is to practice and to learn. But then we're going to go into some application problems and then learn a new skill tonight. So our first warm-up problem is converting 10,700 milliliters to kiloliters. If throughout this live stream you have any questions as to how to get from one step to another, or if you want to tell me how you would solve the problem, please do that, and then we can check our answers together. You can lock in that answer in the chat, and then we'll check it together at the end. So for this first problem, I always start with what I'm given, and I'm given 10,700 milliliters. I then need a conversion to go from milliliters to liters because I only know those numbers to get from milliliters to liters and liters to kiloliters. So liters is kind of that halfway point. It's called a base unit. So I'm going to go from milliliters to liters. I put milliliters on the bottom because milliliters is not in my final answer and I want to cancel it out. So if I want to cancel out something on the top, I have to put it on the bottom. So I'm going to cancel out my milliliters, and then I want to go from liters to kiloliters. Same thing with the milliliters. If I want to cancel the liters out, I have to put liters on the bottom, kiloliters on top, and then I'm going to just fill in those conversion factors. If you know any of the conversion factors, type them in the chat. If you know how to get from liters to milliliters or liters to kiloliters, let me know. I'm going to give y'all about 5 seconds. 5, 4, 3, 2, 1. All right, so we know 1 liter has 1,000 milliliters. Milliliters are a lot tinier than liters. And then kiloliters, we know 1 kiloliter has 1,000 liters. Kiloliters are a lot larger than liters. Then I'm going to put that into my calculator. So we multiply the top and we divide the bottom. So what we'd put in the bottom, we'd put our 1,000 times 1,000 in the bottom. And so what we put into that calculator is 10,700 divided by 1,000 divided by 1,000. So I'm going to give y'all about 30 seconds to put that in the calculator and let me know what you guys get. All right, we're going to go for about 10 more seconds. If you know what it is, lock in your answer in the chat of Twitch, TikTok, YouTube, whatever you're on, lock in that answer. 3, 2, 1. If you said 0.0107 kiloliters, you are correct. All right, and I want to remind you guys again, if you have any questions, please type those questions in the chat so that I can answer them for you. That's what I'm here for, is to answer questions for you. I'd be more than happy to help you with whatever you need for stoichiometry. So please type those questions in the chat and feel free to be as interactive as you want throughout this. All right, now for our next warm-up, we're going to write 6.6 billion, 20 million. That's a big number. I think that is 6 billion and 20 million, but who knows? Anyways, let's write this in scientific notation. So the best way that I like to do that is if I have my number, I start where the decimal point would be if there's not a decimal point already, and I move it to where there's just one non-zero number before my decimal point. So one non-zero number to the left of my decimal point. Then I'm going to count that number of humps that I created. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, any of the non-zero numbers I'm going to couple together with that decimal point that I moved, so 6.02. Then I'm going to do times 10, and then I'm going to add my number of humps as the power. So I have 9 humps, so times 10 to the 9th. And that's how I put that in scientific notation. Now I'm going to give you guys a challenge problem to do for this. I want y'all to put 0.0000483 into scientific notation. You guys have 20 seconds. All right, we've got 5, 4, 3, 2, 1. Okay, to do this, it's very similar to our last problem. We're just going to move that decimal point this time to the right. And then I'm going to count those humps. So remember, we want one non-zero number to the left of the decimal point. So I'm counting 1, 2, 3, 4, 5. And I'm going to do 4.83 because I take all those non-zero numbers. I have that one number to the left of my decimal point. And then this time, since the number is super small, it's going to have a negative exponent. Negative exponents clue you in not for a negative number, but for a small number. So negative exponent means small number. So this is 4.83 times 10 to the negative fifth. If you guys got that right, let me know so that I can see how we're doing on scientific notation. If you're just now joining the live stream, welcome in. I'm so glad to have you. My name's Allison. This is the Chegg Stoichiometry Office Hours. We have office hours all week for different classes and courses that I encourage you to join. And if you have any questions about stoichiometry, type those in the chat. I'd be more than happy to answer them for you. Next, we're going to find the molar mass of C8H14O3. So this one is a little bit difficult for molar mass. Molar mass, we're trying to figure out how many grams of a substance is in a mole of that substance. So to do this, we need our periodic table. And you're going to find the mass for each of these individual elements. So I know I have 8 C's, 14 H's, and 3 O's based on this chemical formula. I'm then going to go to the periodic table and find the molar mass of each individual element. So for carbon, if I go to the periodic table, I know that that molar mass is 12.01, and I'm going to multiply that by 8. Then if I go to hydrogen, I know that molar mass is 1.01, and I'm going to multiply that by 14. Then if I go again to the periodic table and look for oxygen's molar mass, I know that number is 16, and I'm going to multiply that by 3. I'm going to give y'all about 10 seconds to do those simple multiplication problems in your calculator. If you can do it in your head, I'll be very impressed. But let me know what you get for those multiplication problems in the chat, guys. Give y'all about 10 seconds. 5, 4, 3, 2, 1. Okay, if you said 96.08 for the first one, you are correct. If you said 14.14 in the second one, you are correct. And if you said 48 for the third one, you are correct. Good job, guys. Now we're going to add all of those together to get the molar mass. So I'm going to add 96.08 plus 14.14 plus 48 into my calculator, and you should have gotten 158.22. And does anyone know what the units for molar mass are? I know a lot of chemistry teachers like to quiz you on units, so this is always an important thing to know, is like what units what you're calculating has. I'm going to give you all about 3 seconds to type that in the chat. What units does this have? If you said grams per mole, you are absolutely correct. That is 158.22 grams per mole is what we just calculated. All right, now moving on. We want to convert 348 grams of oxygen to moles of oxygen. Again, if you have those questions, please ask them. That's what I'm here for. I would love to answer any questions you all have so that we can all learn together. And welcome to our Chegg Stoichiometry Office Hours if you're just now jumping in. All right, we're converting 348 grams of oxygen to moles of oxygen. So I'm going to start out with 348 grams because that's what I'm given. And then this is a pretty simple problem. I just want to get to moles. So I need grams to moles. And how do I get from grams to moles? It's basically what we just did in this problem above, using that molar mass. So we need to find the molar mass of O2. And the molar mass of O2 is just 2 times the molar mass of oxygen. So I'm going to do 2 times 16. Hopefully, we might not have to put that in our calculator. It should just be 32. So I'm going to put 32 grams in 1 mole of O2. And then we multiply the top and we divide the bottom. So if we do 348 divided by 32, let's put that in your calculator. I'm going to give you all about 10 seconds to tell me what that answer is. All right, 4, 3, 2, 1. If you said 10.875, you are absolutely correct. There's just one little thing we want to fix is significant figures. So significant figures, make sure we have the same amount of digits that we started with as what we ended with. A lot of chemistry professors test on this. So if you use correct significant figures, your answer should be 10.9 moles. If you got that, let me know so that I know that we're all learning it. But hopefully you guys are learning something new. I encourage you to ask any questions you have. If you're just now hopping into the office hours, hello. I encourage you to check out the QR code up at the top left to find all of our office hours for the entire week so you can get help for all of your classes. All right, now we're going to do a little bit more complicated of a problem. It's 2 steps, top and bottom units, so it's a little bit more difficult of a conversion. But just like always, we start with what we're given, and we're given 84 meters per hour. Now, I want to focus on 1 unit to get to my end unit. So first I'm going to go from meters to centimeters. I always like to start with the top. It doesn't matter what you do as long as you put those on opposite sides, top and bottom, so that they can cancel out. So for meters and centimeters, I'm going to put meters on the bottom so it cancels out meters on the top, and centimeters on the top, so because centimeters is on the top in the final answer that I want. Then I'm going to focus on my hours. I want to get from hours to seconds. So I'm going to put hours on the top, and I don't know the conversion from hours to seconds, so I'm going to put minutes on the bottom. Then I'm going to go minutes on the top, seconds on the bottom, so that in the end, I am going to get that centimeters over seconds, which is what the problem is asking. So I know 1 meter has 100 centimeters in it. And then I know 1 hour has 60 minutes, 1 minute has 60 seconds. So those are all the conversions. Now, I'm not going to tell you all this time how to put it in the calculator. I want you guys to do that. So you have about 30 seconds to put that in the calculator and give me an answer. Let's see how well we're doing with those top and bottom conversions. All right, y'all have got about 20 more seconds. About 10 more seconds. 5, 4, 3, 2, 1. Okay, guys, if you said 2.3 centimeters per second, you are absolutely correct. Great job, guys. And remember, type those questions in the chat so that I can answer them for you. I'd be more than happy then to answer them. That's what I'm here for. Thank you so much for tuning in to Cheg's live office hours this week. This is Stoichiometry. All right, now I wanted to move on to some application questions because when I TA for chemistry, I always get a lot of questions of like, how is this going to help me in the real world? How is this going to help me in my job? So this first one, if you're a nurse or a doctor, if you're going to school for either of those, this application question is for you. This is 100% something you're going to see day to day in a hospital or doctor setting. So the question is, a doctor orders a patient medicine that has 10 milligrams per 8 milliliters. The patient needs 2 milligrams per kilogram of body weight and weighs 46 kilograms. How many milliliters does the patient need? All right, so Does anyone have any ideas on how we would start this problem? This is a challenging problem. So I would encourage y'all, type in the chat, how do we start this? I will be so impressed. This is a hard one to start, but let me know how we start it in the chat. I'm going to give y'all about 5 seconds to let me know. All right. 3, 2, 1. So we can kind of in this problem start with two things. We can start with 10 milligrams per 8 milliliter or 2 milligrams per kilogram. I think in this problem, it's going to be easier to start with the 10 milligrams and 8 milliliters. So I'm going to put 8 mLs on the top and 10 milligrams on the bottom. The reason I put the milliliters on the top is because I'm going to end in milliliters. So basically my goal is I want to get rid of that milligrams. And how do I do that? So we can think of this logically or like a puzzle. I think more in a puzzle way, but I know some people think more logically. So if I have 8 milliliters in this 10 milligrams and I need 2 milligrams per kilogram of body weight, what I would do is I'm going to cancel out that milligrams first. I'm going to put milligrams on top, and I have a conversion factor right here for 2 milligrams per kilogram. And I know I can cancel out that kilogram by multiplying it by my patient's weight, because that tells me how many milligrams of medication I need. If I multiply that 2 milligrams per kilogram by my patient's weight in kilograms, I'm going to get how many milligrams I need. And then I can use that milligrams per milliliters to figure out how many milliliters. That's the logic way. This right here, what I'm showing on the paper, is the puzzle way if you like to do puzzles in your brain. So then I'm going to multiply by that 46 kgs. Now, if I cross out all my units, that cancel. So my milligrams and my kilograms, there's an imaginary one with that kilogram if it doesn't give a number. I'm going to be left with milliliters, which great for me is what the problem asks for. It asks for milliliters. So I'm going to put that in my calculator, and that's how I'm going to get how many milliliters of the medication my patient needs. I'm going to give you all about 30 seconds to tell me what you get when you put that in the calculator. And definitely check yourself once or twice so that you know you get the right answer. I always know when I took chemistry, checking myself on my calculator saved me a lot of points on exams. All right, about 10 more seconds. 5, 4, 3, 2, 1. If you said 73.6 milliliters, you're absolutely correct. That is a lot of milliliters to give a patient, but maybe it's like in an IV or something if you want to think of it that way. But again, if you're a nurse or a doctor, this is a very practical way of how stoichiometry will help you and how you will use it in your day-to-day life. Now, for all my chemistry, biology majors, whoever wants to work in a lab, if you want to be a science teacher, you might come across this. This is a problem for you of how you would apply it. So we have glucose, which is this right here, C6H12O6, reacts with O2 to form CO2 and H2O. What mass of oxygen in milligrams is required to completely react with 54 milligrams of glucose? All right, there's a few things we need in this problem. First, we need to find the molar masses. If you guys can figure out the molar mass of glucose or oxygen, let me know. I'm going to give y'all about 2 minutes to figure that out. I'm going to be writing how to figure it out on the whiteboard. So if you want to come check your work, do that. But I encourage you guys to try to find the molar mass of glucose in this O2 by yourself. So to start, I would do my C6H12O6, 6 times my carbons, 12 times my H's, 6 times my oxygens. So 6 times 12.01, 12 times 1.01, 6 times 16. So multiplying across, I'd get 72.06, 12.12, and 96. Then I'm going to add all those together to get my molar mass. So I'm going to give y'all about 20 seconds to put that in your calculator. All right. 5, 4, 3, 2, 1. If you got it, lock in your answer, type it in the chat so I know that you guys are following and understanding what we're learning. If you got 180.18, you are absolutely correct. Great job, guys. Now we are going to do oxygen, which we did earlier. It's fairly easy, just 2 times 16, so 32. All right, now that we have that, it is time to solve our problem. Those are just key components that we're going to need. Now we need to get from our 54 milligrams of glucose to our milligrams of oxygen. So if I start with 54 milligrams of glucose, my conversion from molar mass is only grams to mole. So I'm just going to put milligrams of G for glucose. So then I need to go to grams of glucose. I know 1 gram has 1,000 milligrams. Then I need to go from grams to moles of glucose. That is going to be what we found over here. So that 180.18 grams per mole. That's going to tell us how many moles of glucose we have. So that's the first kind of key step to this problem. I'm going to give y'all about 30 seconds to put that in your calculator and figure out the answer. All right, 5, 4, 3, 2, 1. If you got 2.997 times 10 to the negative fourth moles, you're absolutely correct. Now, let's find, we need a conversion from moles of glucose to moles of oxygen. So we're going to work on this a little bit more later, but the key for something like this is we need to balance a chemical equation. So we would do C6H12O6. It reacts with O2 like we see here, so we need the O2 on the left side of the problem plus O2 yields CO2 plus H2O. Okay, this is another challenge. Let me know how you balance this equation. I'm going to give y'all about a minute to try to figure it out. We're going to balance this, so I encourage you, if you can solve it before I can, let me know in the comments. Try to beat me. But this is how I would do it. First, I notice I have 6 C's over here, so automatically I put a 6 there because I know that my carbons on one side have to match up with my carbons on the other. Next, I notice I have H's 12 over here, so I'm going to put 6 in front of that H2 to get 12 H's. Now, I'm going to count up my number of O's, and then I can leverage that with that O number right there. So on the right side of my equation, I have 6 times 2 equals 12 O's plus 6 O's, so I have 18 O's. This right here gives me 6, so I know I need to put a 6 in front of here because 6 plus 12 will give me 18. Then I do a final check to make sure my elements on one side equal my elements on the other. So I have 6 C's, check. 6 C's, check. 12 H's, check. 12 H's. And then 6 plus 12, so 18 O's plus 12 plus 6, so 18 O's. So I know my equation is balanced correctly. So I have that equation. Now I need to use it to get from moles of glucose to moles of oxygen. So I start with 2.997 times 10 to the negative 4 moles of glucose. Then I go to moles of glucose, cancel out top and bottom, 2 moles of O2. I go back to my chemical equation. I see 6 is my mole number for oxygen and 1 is my mole number for glucose. So I put a 1 with my glucose and a 6 with my oxygen. I'm going to put that in the calculator. I'm going to give y'all about 10 seconds. Put that in the calculator. Let me know what you guys get. And remember, any questions you have, ask those to me. That's what I'm here for. I want to teach y'all as much chemistry as y'all want to learn. Okay, if we put that in the calculator, we get 1.79 times 10 to the negative 3 moles of O2. Now, our final step, our problem asks for milligrams of O2. So I need to get that 1.79 times 10 to the negative 3, 2 milligrams. So 1.79 times 10 to the negative 3 moles of O2. Then I can do moles to grams. And to get that conversion, I'm going to go back to that molar mass I found, which is right here. So I know 1 mole has 32 grams. And then I want to go to milligrams because that's what the problem asks for. So I have 1 gram is 1,000 milligrams. I'm going to give y'all 30 seconds to put that in your calculator. Try to beat me in getting that in. Let me know what you get and lock in your answer so that we can check at the end. You have about 30 seconds. All right, 10 more seconds. 4, 3, 2, 1. If you said 57.5 milligrams, you are correct. Great job, guys. I'm so proud of us tonight. Remember, ask those questions. I want to answer them. If you're just now joining our live stream, welcome. It is so great to have you. I'm so glad you chose Cheg's office hours tonight. All right. I think we're going to skip this question for right now. I think we have some stuff that is going to be more important and more helpful, and we know how to find mass from moles. That's what we've been practicing tonight. So I think we're good on that. But we're going to go to runners. If you're a runner, this might come up in your running. If you're wanting to convert your time from miles to meters or miles to anything, this is how you would do it. Real quick though, we got a question from user 404 on TikTok. Can you explain how to convert moles? So I'll do a little lesson. This always helped me on, it's like a little flow chart on what we can convert moles to. Hopefully this will help user 404 on TikTok, but you always put moles in the middle. And then around it is what we can convert to. So moles is like our universal unit for chemistry. And that's because we can convert moles to molecules. And we can convert molecules to moles. We can convert moles to grams. And we can convert grams to moles. We can convert moles to atoms and atoms to moles. But we can't convert grams to atoms directly or moles to atoms directly. These are not okay. These do not work. We have no conversions for them. So when we say how we convert moles, we do that by going molecules to moles, moles to atoms. And moles is kind of that middle ground. If you need to get from molecules to grams, if there's a problem you're given to get from molecules to grams, you always have to get to moles first. And then what we've been working on is how to specifically convert that in math. But this is why we use moles to convert, and this is how we convert to moles and how we are allowed to convert to moles. But I encourage you, if you're just now joining in, rewatch that live stream to see how we converted moles throughout and specific examples. But this is kind of our overall review. All right. So let's go back to our running problem. If we have 8.7 kilometers per hour, we focus, this is kind of similar to what we did at the top. We go kilometers to meters. So we'd have 1 kilometer is 1,000 meters, and then we can go hours to seconds. So hours, minutes, 1 hour has 60 minutes. 1 minute has 60 seconds. Then we'd put that all in our calculator and we'd end in meters per second. I'm going to give y'all about 20 seconds to put that in your calculator. And if you got 2.42 meters per second, you are absolutely correct. Great job, guys. Okay, we have a question from Allison on TikTok. Go over limiting reactants, please. All right, so I don't think we have time left to do a whole limiting reactants problem, but I promise if you tune in next week, I will have a limiting reactants problem in there for us. But conceptually, let's go over limiting reactants right now. So let's say we have this problem let's go back to our glucose problem. And let's just focus on this chemical formula, okay? With limiting reactants, we are trying to figure out what is limiting us from creating more product. So some chemical reactions are not equal with both reactants. Some count more towards the product than others. We have a limiting reactant and an excess reactant. A limiting reactant, what that does is tell us how, if we have this much of our reactant, we can only make this much product. And unless we have more of that limiting reactant, we can't make more product. On the other hand, an excess reactant is we have so much of that reactant that it doesn't matter how much we have, we can only make the amount of product that that limiting reactant allows. Even if we had like 6, that means we have more than enough of that excess reactant. So in this problem, without doing math, because glucose is the more complex, lower molar ratio reactant, we know that glucose is probably going to be our limiting reactant and that oxygen is going to be our excess reactant. And what this means is that that limiting reactant is going to limit how much carbon dioxide and H2O we make. Unless we have more of that glucose, we are not making more carbon dioxide or water. But even if no matter what oxygen we have, because that's the excess reactant, we're making the same amount of carbon dioxide and water. I hope that helps your question, Allison. We'll have more of a hands-on example with some math next week. I can definitely do some limiting and excess reactants, but that's kind of a conceptual understanding of how we do that. We are about at time for tonight, but I am so glad that you guys joined us. I encourage you to check out that QR code in the top left. It has all of our office hours for all week. And so there's different courses. Get help on the course that speaks to you or any of the classes. Chegg is so kind as to put these office hours together to help us all really learn. And I will be going over limiting and excess reactants next week, so I encourage you to join. But thank you guys so much, and I can't wait to hear more.